First off, we're going to look at a little vocabulary. So, got a chord up here. A chord it has its is a line segment that has its endpoints on the circle, and that would be CD. Um, you could also say FH if you wanted to. That's a chord. It's a special type of chord. It's a diameter, but it is a chord. Tangent line. Tangent line touches the circle one time. IG. And notice I have arrows on that. Radius, three different options here: EH, EJ, or EF. Any of those would work. Notice that does not have arrows on it. Secant line, it's going to have arrows on it. Secant lines touch the circle twice. That's going to be AB. A, B. Center of the circle is E. Diameter, we already talked about that. It's a chord that goes through the center of the circle and cuts it in half, HF or FH. Point of tangency is where the tangent line touches the circle. That would be point J. These are all central angles. It says that BE and CF are diameters of the circle. So I could cover up half the circle with this BE right here. That's going to cut it in half. And then CF, that's going to cut it in half right there. Okay. So I've been given 42 degrees and 94 degrees. We got to find the measure of arc FE on number 8. FE. Oh, I'm noticing that 42 up there, that these are vertical angles. So that means that that arc is going to be 42. Arc CD. Arc CD. I'm going to cut the circle in half right here and say that left-hand half, 180 minus 42 and 94. So when I do 180 minus the 42 and 94, yeah, that's 136. I believe it's 44. So 44 right there and 44 right there. Number 10, I got arc BF. BF is up there up top. I'm going to cut it in half right here and say 180 minus that 42 up there. 180 minus 42 is 138. Arc CF. CF, that's half the circle. 180, that's a semicircle. Arc CFD. First thing I'm noticing is that there are three letters here, so I know it's going to be a major arc. Arc CFD. That would be from there to there to there. So that's everything except for that 44. So I'm going to say 360 minus 44 and get 316. Arc EBC. EBC right there. Couple different ways you could do that. I'm noticing this is 180. So I'm going to say 180 on the right side plus the 42. 180 plus 42 is 222. Arc CE. CE is right here. I know that it goes this direction, not the other direction, because it's only two letters. The other direction would be three letters, would be a major arc. So CE looks like it's going to be 94 plus 44, 138. Arc BDF, same deal. It's three letters, so it's going to be a major arc. BDF right there. So 180 plus 4, I think it's 222 again. We have two tangent lines. They touch a circle one time, right there and right there. And they meet out at a point out in space somewhere. And we want to find the value of x. Well, these are going to be equal to each other. Those distances are going to be equal. 4x plus 8 equals x plus 1. Subtract the x over here and get 3x plus 8 equals 1. Subtract 8, subtract 8. That's 3x equals, oh man, this was minus 1. That was dumb. So that should be negative 1, negative 1, negative 9. X equals negative 3. which doesn't make too much sense when you plug it in, but when you get on your test, it'll make perfect sense when you plug it back in. All right, we got some inscribed angles here. Find the measure of indicated angle or arc, circle centered at A. So this is my center. So I'm already noticing that what BC is a diameter. It's going to cut it in half. That's going to help at some point. Segment BC is well, there you go, is a diameter. Arc BE is 56. So this is 56 up there. And DF is 130. So I think that's supposed to be D down here. So all of that is 130. And we got to solve for everything else. So angle BDC, let's make sure that we got D right here. Angle BDC, that's right here. I'm noticing that it opens up to half the circle. It opens up to half the circle right there. So it's an inscribed angle. Half the circle is 180. I'm going to say 180 divided by 2, and that is 90. Angle EDB, EDB, that's right here, that angle right there. It opens up to the 56 up top. See if it opens up to the 56. So I'm going to say 56 divided by 2 is 28. 19 says angle BFE. Well, it opens up to the 56 too. See that? How it opens up to the 56. So I'm going to say 56 divided by 2 again and get 28. Angle DBF. DBF. That's this right here. I'm noticing that it opens up to that 130 down there. So I'm going to say 130 divided by 2 is 65. We're going to come back to 21 here in a second. 22, arc BDC. That's half the circle. That's 180. That was working better. Arc EC. EC. That's right here. You see that? EC is right there. I'm going to cut the circle in half right here and say 180 minus the 56 up there. That'll give me what's left over. So 180 minus 56 is 124. And measure of arc BFE. Notice it's a major arc, so BFE is all of this. BFE. So 360 minus 56 is what? 304. I feel like I chopped off one of these. I think there's a 25 on there. Measure of angle CDE. So angle CDE is right here. It opens up to what we just found up here, right? We just found EC. EC was 124. It was number 23. So I'm going to say 124 divided by 2 and get 62. All right, let's go back to number 21. It says angle DGF. DGF is right here. Okay, I'm going to put an X right there. Angle DGF is right there. That's an interior angle. It's not a central angle. It's not an inscribed angle. It's an interior angle. So we have that whole angle equals 1/2 big arc plus small arc right there. So I'm going to say for 21, X equals 1/2 times the big arc is 130 plus the small arc is 56. That's 186. That's 93, I believe. Okay. Next, we got an exterior angle. So we have our formula. Angle equals 1/2 big arc minus the small arc. And it gives me the angle. That's 55. And 1/2 big arc is 175 minus the small arc, we don't know. And we can distribute or multiply by 2 on both sides. If you multiply by 2 on both sides, you get 110 equals 175 minus x. You'll subtract the 175 and get negative 65 equals negative x. Divide by negative 1 and get x equals 65. Hopefully we get that when we distribute here. So I got 55 equals 87.5 maybe. Yeah. Minus 1/2 x. And then I'm going to subtract that 87.5 over to the left side, and that'll leave me with 32.5 equals negative, that's negative 32, sorry, negative 1/2 x. Divide by negative 1/2 on both sides. Make sure you're using the Desmos calculator if you haven't figured that out yet. And you'll get 65. Next, same kind of deal. This one's a little bit easier. I've got the angle x equals 1/2. Big arc is 165 minus the small arc is 57. I don't know what the deal is with my pen. And x equals, what is that? 108, 54 maybe? Next, we got common tangents. So tangents touch the circle in one spot. How many common tangents do these things have? Well, one tangent line would go like this. And another tangent line would go like this. So those lines touch the circles, each circle at one time. Those are common tangents. Touched once right there, once right there. That's a tangent, common tangent line. And then right there and right there, it's a common tangent line. There's one more. And that goes through the middle right there. So how many common tangents? 3. If you were to see a circle like they're separated, then you could do that one, that one, that one, and that one. So there would be 4 on that one. The only other way I could ask that is to overlap the circles, in which case there would only be 2 common tangents right there. In the following circle, the 2 chords intersect at a right angle. So when we have a right angle inside the circle, if it looks equal, it is equal. Okay? If it looks equal with a right angle in there, it is equal. Arc AE is 50 degrees, BD is 10. It wants to know the measure of segment AB. Well, BD and AB look equal. They are equal right here. Arc CD, CD's down here. A couple different ways to go about doing that. I would say, well, if that's 50 up here, then this is 50 right here. And then I could cut the circle in half and say 180 minus the 50 would be 130. Arc CDE, that's just half the circle. It's 180, right? Solving for sides of a triangle. So we're going to use Pythagorean theorem in some form or fashion on both of these. So I'm given 2 sides of a triangle, and I have something missing. That's just that part. It's not the whole thing, but it's just the outside part. I'm going to use Pythagorean theorem, and we're going to say a squared plus b squared. I don't know what the deal is with my pen. A squared plus b squared equals c squared. And I'm going to punch that in my calculator really quickly. 20 squared plus 99 squared equals a really big number. And then we're going to square root that and get 101. So C equals 101. That's not my answer. That's this whole length right here, 101. So I'm noticing that I have a radius right here of 20. I could kind of rotate it over to right here and make that 20. And if I want to solve for x, I'm going to say 101 minus that 20, and x will equal 81. Next one. So I'm given 73 is just that outside part, so I can't really do Pythagorean theorem just yet. I'm going to see this 45? 44, excuse me. It's going to go over there. Okay, so I'm going to move this 44 right here and add all that up to get this whole side. So I think that that is, what, 117 maybe? 117. And now I have two sides of my right triangle. I need to figure out what the third side is. I'm just going to use Pythagorean theorem. So I'm going to say 44 squared plus x squared equals 117 squared. So I've got 44 squared is 1936. What a great year. 117 squared is 13,689. When I subtract the 1936 over to the 13,689, I get 11,753. And the square root of that is ugly, unfortunately. 108.4. On your test, it'll be a nice answer. All right. I'm noticing both of these are inscribed angles. I know that this 5x plus 3 right here, it opens up to this part, right? So I know that that part is 2 times 5x plus 3. If you want to go ahead and call it 10x plus 6, you can. And then I noticed that this 127 right here opens up to all of this. So I can multiply it by 2 and get, what, 254? So I have my whole circle now. That's all going to add to give me 360. I'm going to say 2 times 5x plus 3 plus 254 equals 360. And that's 10x plus 6 plus 54 equals 360. That is a weird plus sign right there. And that would be 260. I think we're going to get 10x equals 100. X equals 10. All right, got to find the value of x here. These are both inscribed angles. There's an inscribed angle, inscribed. They both open up to that arc. That means that their measures will be equal. Like if this said 20 degrees, then that means that this would be 40, and I'd divide by 2, and that would be 20 as well. Okay, so our measures are going to be equal here. If we're just solving for x, I'm going to say 5x minus 2 equals 4x plus 9. That would be x equals 11. Got some fancy inscribed angles here. On 37, I'm going to say 69 times 2, that's 138. 38, I'm going to divide by 2. That would be 70. And on this one, I'm going to say 360 minus the 192. That would be 168, I believe. And if this is 168, then I'm going to divide by 2 and get 84. Last one. we've got CD here. Well, look, this is 152, this arc, and so is that arc. If the top arc opens up to 17 and it's 152, then this 152 on the bottom is going to open up to 17 since the arcs are equal. And then measure of arc DBC, DBC right there. Two different ways. It's a fancy inscribed angle. I could say 2 times 104, that's 208. Or I could say 360 minus the 152 and get 208 too.